Hey, I'm Anita. I'm the maths exams expert, and we're going to be looking at solving surd equations or irrational equations. So, a nice short little lesson here. What we've got to do in it can get a little bit tricky. Only one main objective today, and that's to learn how to solve these equations. And just to clarify that when we talk about an irrational equation or a surd equation, we're talking about one that contains a square root or a surd. So, you can see this equation here is an equation because it has an equals, and it's a surd equation because it has this square root. So there's some steps involved here that we need to be aware of. The first thing we should do is isolate the surd on one side of the equation. Now, these steps will all become a little bit more clear once we start. If there are two surds, put one on either side of the equation. And then the key step is to square both sides. Because when you've got a square root, you can undo it or inverse it by squaring it. But you know what equations are like. You have to do the same on both sides. So if you square the side with the surd on it, you have to also square the other side. And then check your answers by subbing in. That's an important one. We'll talk more about that. Let's get stuck into a question straight away. The first step is to isolate the surd. But since we've got two surds here, what we do is we get one on either side of the equals. So I leave the root 2x minus 1 where it is, and I'll bring the add root x minus 1 to the right, and it's going to become subtract root x minus 1. Okay, next step then is to get rid of those square roots. And how do you get rid of a square root? You square it. You can't go randomly squaring one thing without squaring everything. So we're going to square both sides. So that gives us root 2x minus 1 squared is equal to 5 minus root x minus 1 squared. Now be careful not to do 5 squared minus root x minus 1 squared. That is incorrect. I can quickly show you why it's incorrect. If, for example, we had 2 plus 3 is equal to 5, if we do 2 plus 3 all squared, that will be equal to 5 squared. If, however, we do 2 squared plus 3 squared, that's not going to be equal to 5 squared. That would give us 4 and 9, not equal to 25. So when you're squaring, you can square both sides, but squaring each term in an equation is not a valid move. So let's square both sides. Now the left side is easy enough because when we square a square root, it cancels out. They're inverse operations. So that's just going to leave us with 2x minus 1. The square and the square root are gone. On the right-hand side, it's not so straightforward because there are two terms going on here. So I'm going to expand out, square out this bracket fully. And I'll leave the left side as it is. And we're going to do that business where we do the first times the first and the first times the second and so on. So 5 fives is 25. 5 times negative root x minus 1 is going to be minus 5 root x minus 1. Negative root x minus 1 times positive 5 is again going to be negative 5 root x minus 1. And then the last one is negative root x minus 1 times negative root x minus 1 is going to give me negative times negative is positive, and root x minus 1 times root x minus 1 is root x minus 1 squared. Okay, let's do a little bit of work on that. The left side is fine as it is, nothing to be done there. Minus 5 root x minus 1 minus 5 root x minus 1. It's like it's minus 5 things minus another 5 things is going to be minus 10 of those things. So negative 10 or minus 10 root x minus 1 plus. Now we've already seen how when you square a square root, it cancels. So that square root is going to go away, leaving us with plus x minus 1. Let's now have a stop and have a look at what we have. We've got things we can definitely tidy up, okay? Like terms we can bring together, but we've still got a surd. And the whole point here was that we were trying to get rid of the surd, and yet we still got one. However, we had two surds, now we've only got one. So it's progress. This will often happen in these questions where you've got to repeat the process twice. This time will be a little bit easier. Because there's only one surd, we'll just get the surd to one side of the equation and then we'll square both sides again. Now, will we put that surd on the left side, or will we leave it where it is on the right? It doesn't really matter. So let me write a little note about this now. What have we got? So that negative 10 root x minus 1, I'll bring it to the right so it'll become positive, and that'll just make me feel a little bit happier. And then what am I left with on the left? I've got a 25. I've got a plus x. I've got a minus 1. I've got this positive 2x, which I'm going to bring across, and it's going to become a negative 2x. And that minus 1, I'm going to add a 1 there on the right-hand side. So small little bit of tidying up there before I go squaring. I've got 1x minus 2x is minus 1x. 25 minus 1 is 24. Oh, those minus 1s plus 1s cancel out. Plus 25. Okay. So now again, we're going to square both sides. So again, 10 root x minus 1 all squared is equal to same thing again. Remember, we can't square each term individually. We have to square the whole thing. So what have we got then? When we square this, remember, this is one term. The 10 is multiplied by the root x minus 1. It's all one term. So when we square this, if it's two things multiplied together, because you may know that ab squared is a squared b squared, and that's not the same as a plus b squared, which is the whole expanding out of the bracket thing. So what we've got here then is we've got two things multiplied together. We can square the first and we can square the second. So when we square the 10, it becomes 100. When we square the root x minus 1, the root goes away. On the right side, however, we've got two terms. So we are going to have to expand out this bracket fully. Expand that bracket on the left. Now, what have we got going on here? That times that, and that times that, and that times that, and that times that. Minus x times minus x is plus, oops, wrong color, is positive x squared. Negative x times 25 is minus 25x. Negative 25 times minus x, minus 25x. 25 times 25 is 25 squared, which I believe is 625. Right. Do you see what we have now? The thirds are all gone. It's looking a little bit quadratic, and that feels good. We know what to do with that. So let's bring everything to one side and let it equal to 0. I'm going to bring it to the right because the x squared is positive on the right. So minus 25x minus 25x is minus 50x. Minus 50x, bring that 100x across, minus 100x, minus 50 minus 100 is minus 150x. Oh, it's going to get messy. Is this going to be a minus b formula, or do you think we'll be able to factorize it? Let's see. 625 positive, bring the 100 across, plus 100 is plus 725. Not looking very good there, is it? All right, so it's not looking too good, but I'm going to tell you that it can actually be factorized. But I'll be honest, guys, if I was looking at these numbers in an exam, I'd be headed for the minus b formula. But just to speed us up a little bit, I'm going to tell you that if this can be factorized, it's a 1, 4, 5, and a 5, and minus, and minus. So that gives us x is equal to 1, 4, 5, and x is equal to 5. If the factorizing of the trinomial there is tricky for you, there's video in Algebra 1 that'll help you with that. Right, hang on, what was I doing? I was solving for x. There's no y's here. This isn't simultaneous. So I solved for x, and I've ended up with two answers. Lovely. Which one of them is right? Maybe they're both right. Now, I said in the notes at the beginning that you have to sub your answer back in again to check. If you don't do that, you will actually lose exam marks. It's not just an optional extra to check if you're right. You have to, because when you square both sides of an equation, there's always a risk that you will introduce extra solutions that aren't actually valid. So we're going to check. Let me write down my equation again. Okay, so when x is equal to 145, we've got the square root of 2 times 145 minus 1 plus the square root of 145 minus 1. And is that equal to 5? So when I put all of that into my calculator, I get 29, which is not equal to 5. Therefore, I'm going to reject that solution. And it's very clear that you stated that you're rejecting it. So let's check the other one. So that's an extra solution that got introduced by the squaring here. So we have got the square root of 2 times 5 minus 1 plus the square root of 5 minus 1 is equal to 5, which gives us the square root of 10 minus 1 is 9, that's 3, and square root of 5 minus 1 is 4, that's 5. That gives us 5 is equal to 5, which is correct. So my solution is x is equal to 5. Okay, and you guys can get started on the question on the right. All right, so you'll see there that our two solutions satisfied the equation when we sub them back in. So both are valid in this case. Right, before we finish up, there's just a little exam tip I wanted to give you here, and that is to make sure you pick up every last mark. I know I've said this within the video, but I'm saying it again because it's important. When you're dealing with surd equations, there is an expectation that you check your solutions by subbing into the original equation. It's not an optional extra. You must do it, and there will be marks going specifically for that step. So make sure you don't neglect it. Okay, that's it for this video. I'll see you in the next one.